In Unit 4, Activity 7, they go through acid and base equilibrium. So we've done equilibrium with gases, we've done equilibrium with salts, and now we're doing acids and bases. I'm going to focus on acids, and I'm going to show you what happens with a strong acid or a normal acid versus a weak acid. The weak acid is the one that's in equilibrium. With a strong acid, so let's go through this one first, just so we can understand what a weak acid is. With a strong acid, it dissociates 100%. So this is the acid. Let's say it's HCl, for example. HA is the common abbreviation for an acid. The H is the hydrogen, the A is the anion, or the end part. When we put acids in water, we activate them and we make H3O plus hydromium. This is what's actually acidic right here. It's not this. This breaks down in water to make H3O plus. The A minus in this case would be Cl minus. It would be the end part of the acid. We don't care about that. When this breaks down, it breaks down 100%. So if you start with 0.01 molar, you form 0.01 molar of the hydronium. If we take the log of 0.01, we will get a pH of 2. Remember, you'll get -2, and that's why we put a negative there, because the negative of negative is positive. The other thing you can do is always remember to make your answer positive. Just a little shortcut. You know the pH is going to be 2 here because what pH does is it counts decimal, or what log scales do is count decimal places. 1, 2. That 1 is the second decimal place, therefore a pH of 2. Okay, that's a strong acid. That's an acid that breaks down 100%. You start with 0.01 molar of HCl. You end up with 0.01 molar of H3O plus. Let's look at a similar situation with a weak acid. If we start with 0.01 of a weak acid, and you'll know it's a weak acid because you'll find it on a Ka table, or it will say weak acid in the question. So you'll always know if it has a Ka value, it's a weak acid. When we put it in water, it does not break down 100%. It breaks down much less. The amount it breaks down we will call X. Our formula that we need to figure out X is Ka equals X squared HA minus X. Remember, HA is that value right there. This X will be negligible, so we can get rid of that. So it becomes Ka equals X squared over HA, and we can solve for X. Now, some of your questions tell you to solve for Ka. In that case, they have to give you X and they have to give you HA for you to be able to do that. So if we put 1.8 times 10 to the negative 5 equals X squared over 0.01. Let's try and do this calculation here. I'll just be 1 second. I have an X value of 0.0004, I believe. If I take the log of 0.0004, it's going to be close to 4, because this number here is the 1, 2, 3, 4th decimal place back. And I've got 3.4. Notice that the strong acid and the weak acid were the same initial concentration. The strong acid breaks down completely. Take the pH, we get this. And this one does not break down completely. If it's a weak acid, you have to put it through this formula here and then take the log of that answer. Now, let's do another calculation. If they give you the pH in a problem and they tell you to calculate the Ka, what you can do is you can find X. So if you know pH, you can find X. Go 10 to the minus pH to come up with your X value, which 10 to the negative 3.4 would be 0.0004. This formula only works if you put the negative of 3.4 in here. You have to hit the second function button on your calculator, then hit log, then type in negative 3.4 to do that. So if you put 0.00004 in for x and you put 0.01 in here, you would get this Ka value right here. Folks, this is just a number of calculations that you can do for a weak acid and a comparison of weak acids to